Okay, so air pressure is all around us. There is always air pressure at the moment. As you change your height, as you go up in the atmosphere, you might change the air pressure you experience. That's why you pressurise the cabins of aircraft that are up 30,000 feet. So air pressure is the pressure of the air acting on you all the time. At sea level, it's given a value, which you're not given your data book, but should you have to use it, you will be given it. So at sea level, air has a pressure of 1.01 times 10 to the 5 pascals, which means that you have that pressure being applied to you right now. When air is removed from a plastic bottle, it is this pressure pushing on the outside which causes the ball to collapse. So we've always have this pressure. When you remove something, you're not sucking the walls in, you're sucking the air out, which causes the air on the outside to collapse it, to push in really hard. Pressure is force per unit area, so if you know the surface area of the bottle, you know the atmospheric pressure, you can work out the force by which it's going to get collapsed at, going to be forced in at. Right. So at sea level, air has a pressure of 1.01 times 10 to 5 pascals, which is the same as newtons per kilogram. When air is removed from a plastic bottle, it is this pressure pushing on the outside which causes the bottle to collapse. So this pressure, fixed surface area, you have the force. That amount of force that's required to do that. Okay? So pressure is not so much about there simply being pressure there, it's is there a pressure difference? The pressure difference causes things to happen. So pressure difference, if I pull the air out of a bottle, I'm removing the air, so I'm removing any pressure there was on the inside, meaning the outside has more pressure, so it pushes it in. So if you want things to happen, if you want a force to be applied, you have to make sure there's a pressure difference. That difference in pressure would cause your force. Okay? So air pressure is one thing, but then we have pressure difference, which causes things to happen. So let's take the plastic bottle example again. So by removing the air from the plastic bottle, or from the bottle, we have removed the pressure. This causes a pressure difference. It's the pressure difference over the area which causes the force. So, in any example where you have a difference in pressure applied to the same object, then a force will happen. You'll find a force will be created. So any situation where there's a difference in pressure, then there is a force applied. Because the surface area is the same. Any one object whose surface area is the same, you apply a difference in pressure, you create a force. So,
So what does that say after the pressure difference?
Over.
Before the area. Over the area.
Oh, it's different.
okay, so any pressure difference for a object causes a force applied to that object.
An
Of
object.
an object.
Does that make sense? Any pressure difference for an object causes a force applied to that object. Because the object has the same surface area, it's the same object, it's just if you have a difference in pressure happening in an object, maybe the inside or the outside of the object has difference in pressure, therefore there's a difference in force causing it to expand or to be compressed. Or what we're going to show now is water pressure. How water pressure shows a difference, it gives us a difference in pressure which gives us a force.